All right, welcome everyone to our monthly HEIR working group meeting for April. And this month we've had 47 PRs merged, which is a little bit less than last month. But I think we'll make up the progress in the next month. Just a couple of updates on what's been going on. There's just a little bit of miscellaneous updates. Vedant has been working on porting his work, so there was a little bit of updates about graph utilities. I think this is just a Fallout fix issue from a while ago that Alex had submitted. I don't know if this is like part of a particular work. linalg.reduce, this is another support for the reduce operation. This is from Alice. So this supports a kernel that just does a log2 style rotate and sum for a reduction operation. So that should give us a little bit more torch coverage if you use the torch to linalg pipeline. And then Edward has been working on the ROTM dialect port. So this is the first PR that that adds the ROTM dialect and adds the ROTM.dim attribute to represent the layouts. So we are starting that. All right, going into a little bit of things, we have a bunch of bug fixes, some splat layout fixes, some crash issues that were happening. So nothing too crazy here. We do have some more docs out now. So Jeremy added this small Bazel cheat sheet in this PR. So this will give you kind of the basic commands that you need, maybe some like gotchas, how to make your Bazel test and Bazel build commands faster if you don't want to like be building the end-to-end tests. So take a look if you need that. And then we also have a bunch of like build and tech debt stuff. I'm not going to go through this in particular, I think. I don't know if there's anything I should notably call out here. I think I gave this update last time. I think PyPI packages should be up now, and our nightly releases should also be working. And they should be alerting us whether or not they actually fail. So next up, I guess one of the pillars that we've been working on was loop support. So Jeremy added a bunch more support here. Jeremy, I don't really know what the current status is though, like where are things out?
So the current status is there's still a few bugs to iron out with regards to like how much loop unrolling is supported. It's like the loop unrolling is fine and supported, but then I can run an end-to-end like matrix vector multiplication with the looped kernels, but if I pump up the level budget too high, it crashes on something, and I just haven't had time to finish figuring out what that issue is. But yeah, so like I hope next week maybe I'll have a chance to finish that, and then it's just a matter of like, you know, there's some open questions about how we set the level budget appropriately, because this is happening before we decide what the level budget is, and then making sure that the result is performant enough.
Yeah. There are also a bunch of flags that you need to set, including this level budget flag. So I think in that MadVec example, if you want to try it out, use that as a reference for what flags you should pass in.
Mm-hmm.
And then
I guess one more interesting thing from that was because there was a situation in which we have loops with if statements in them, and one of the if statement branches is not doing anything, but it needs to, but it's in the first iteration of a loop, that else branch emits a plain text. And in other iterations, it emits a ciphertext. And so we had this issue where you need to have the same type coming out of the if statement. And so there's this one that she's highlighted where I added a support to do trivial encryption as addition. And so what it will do is it will insert an extra encryption of 0 of the right shape, and then you will add that to your plain text with a plain text ciphertext addition, and then that will like resolve that type discrepancy. So there's like a couple of like, I don't know if I'd call them useful, but this is for like backends that don't have like a native API for doing trivial encryption of some value.
We do have a CKS or trivial encrypt, right? And this was
Oh, we do.
And then this is your lowering for the extra backends that don't support it?
Yes, but there are no backends that support it.
Okay.
So eventually I want to have like a backend config thing that you can say, okay, here's all the features that this backend supports that would support this. That would also have like a cost model and stuff. But yeah, so that was just sort of a random thing that I had to do to get this to work.
Right,
Yeah, I think the same would be true for the Orion ops, for example, which we like. I think those should really live in CKKS, given that they're fairly common actually in libraries that aren't OpenFHE. But like then we do need a list of like CKK ops that you must support and lowerings between them, right? But yeah.
Yeah, I think we do need to kind of work on a larger scale change on that. That might be like another big sprint target style thing, but we have flags lying around now, and we have like things that should be like backend configurations. And I think, yeah, there's like some design that needs to happen on how we enable some of those configurable rewrite patterns to lower or not lower. All right, and then this pillar was kind of on polynomial lowering. Everything kind of is bunched up in here. So there's been lots of like plumbing through new type interfaces. There's been lowering NTT with the RNS support. Let me think. There's like, yeah, there was like a bunch of cleanups as well to some of the type interfaces and types in general, I think. And I also don't really know what the like current end state progress is.
Yeah. So the basis extension part of relinearization is the last step. That has an open PR that's waiting to be reviewed by me. And then I think once that's checked in, there will probably be some more end-to-end testing. And but it's like after that, I think relinearization can be lowered to LLVM. And so we will add some end-to-end tests to make sure that it's actually doing what we want it to do. Since we have encrypt and decrypt, I think we can do a full encrypt, mul, relinearize, decrypt, and make sure that it works. And so that is, I think, gonna finish off most of the changes of the polynomial dialect. After that, I think the last things we need to do, I believe, automorphism and bootstrapping. But bootstrapping should probably be the easier of the two because it's composed of 4 things that we already know how to do. Automorphism, I don't know enough about what needs doing there.
Automorphism should also be relatively easy.
It should be because it's just polynomial. It's just like monomial multiplication, right? So yeah, but maybe there's something I just don't know about. I've never implemented it myself.
The key switching, I guess, is going to be the hard part, which is.
Well, I think that relinearization subsumes key switching, right? So yeah, I don't know how much of that can be shared, but it should hopefully be straightforward. I think there will be,
at least initially when I was still on the meetings with Eric, we specifically discussed how to define the key switching op and API in order to make it work both for relin and rotate. He might have had to like relax that a bit in order to make it actually work. But I think at least initially the idea was that you literally just call it differently. We had a whole conversation about like how to interpret a relin as a proper key switch. And like with the API we define, like that should literally be the same key switch op and the same lowering for rotate.
I believe so.
We just need to actually do the permutation, which is not, well, it's conceptually easy, but might again run into annoying limitations of the type system where we end up figuring out that we need to lower or raise or something. I think this has been the big story of this, right? Is that like by having really nice stack type hierarchies, actually sometimes that really gets in the way of just doing the crypto algorithm.
I don't think we've completely proved that yet, in that we've been able to manage by just like adding appropriate ops at the LWE level. Have like access to some underlying things. But yeah, I think the other question that hasn't been resolved yet is like, who exactly is generating this key material and how does it get inserted into the IR? So all of our examples just assume there's like an extra SSA value magically from nowhere that contains the relinearization key and the automorphism key. So we're going to need to figure out at a higher level how those get into the IR. Like it's going to be in generate client side, right? Client helper is going to be doing it.
For the relin key, I assume for many libraries, you can assume that you can magically get it from somewhere. Like
from the crypto context, yeah.
For the rotation keys, you do need to actually pick the right one, right? So that will be a bit of a, like, you do need to pick the right rotation key.
Right. Yeah.
So I don't know, I don't think that should be hard, but I guess that's going to be slightly more difficult than just here's a reading key from context.
Right. Exactly.
Yeah, you'll probably need to hold on to some extra context of the map or something to be able to fetch the right one. But yeah, that's good. That's exciting. And then on the convolution support, a couple of PRs here, and a lot of them are in progress. I think just awaiting Jeremy's arrival home to review. But I did a bunch of basically like this. I think all this work is just testing mostly, and then like stuff around adding the right layouts to the right operations at the propagation step and the optimization step. I guess I'll just transition to the in progress stuff on this as well. But on the
we can actually talk about convolution a little bit. Maybe we should wait.
Yeah.
We'll wait until okay.
Good.
Yep.
Oh, okay. Maybe you guys have to. Yeah. So I can. I'll just quickly finish the in progress part of that. So I guess I literally just pushed all the in progress things, but I can now run a convolution end to end in Latigo, which is nice. I tested it on the first pooling layer of Lynette, which is like maybe 10 channels, 28 by 28 size, and it's a pooling to 14 by 14. That takes 40 seconds right now, including the pre-processing time and probably including and not including a bunch of optimization. So the fallout from this is we currently don't support doing row interchange. I just haven't flipped the bit yet. It's all there in the like actual utility support. I just haven't flipped the bool, just for testing purposes. And I also haven't supported padding channels. So like I'm just hoping that the channels are padded appropriately to support the row interchange. That's why I haven't really flipped it yet. But yeah, that now currently runs in about 45 seconds. So yeah, 2D convolutions that are MIMO style are running now, minus this fallout that has a bunch of optimization to do. What else is in progress? Let's see. So I think there was, this is the basis extension from that Jeremy had just mentioned from the polynomial lowering part. Alex submitted this PR about the Cheddar GPU back in this morning.
Yeah.
Yes. And it's not even reviewed yet. What are you guys doing?
Yeah.
So it's in progress. Yeah.
Yeah. And this is what I mentioned. Okay, I guess the fallout to kind of note about the convolution support. So now like Conv2D MIMO is possible minus channel padding and row interchange. And the issue that I had, the reason why this took longer than it should have taken was because running the ISL loop materialization was really slow for convolution, because our schedule for lowering that into or rewriting that into a loop was just going over the CTs and slots, and it's a fairly complicated relation to actually figure out the right packing given the CT and slot indices. So instead, for convolution 2Ds, I add in the F and C indices of the convolution and then parameterize the schedule over FC CT slot and then build my loop nest like that. So my loop nest now has more indices, which means the loop nest is a little bit more inefficient, but the generation of that loop is a lot faster because it's less complicated to figure out now. So all in all to say is the packing code that is generated is now more inefficient, but the compilation pathway is more efficient. So hopefully that doesn't end up into too much of a burden, especially since we're expecting that to just be pre-processing time anyway.
I feel like that could explain why the pre-processing is so slow. Like
it could, yeah. I did wonder about that. I initially thought that it must just be because, you know, now I'm looping over 4096 times 64, which is the number of ciphertexts times like 10 channels and times one batch maybe or something. So it's a little bit more expensive. Well, a lot more expensive, but otherwise the compilation time was like upwards of 20 minutes.
Are there any upstream loop optimization parts that we can just throw at this to see if they make it magically better? Because for once, this is literally just normal machine learning loops, right?
Yep.
I missed the very first part of that, but were you saying
upstream passes, like MLIR upstream loop optimization passes, we can throw this because this is just normal program at this point, right?
Yep.
Well, so the thing is, there could be. So it looks like a for loop, for loop, for loop, for loop over all the scheduled indices, and then a very complicated if statement, and then the schedule.
The if statement, yeah.
So
But
yeah,
the if statement is what affine, like the problem, I think the problem is not that we can't do it, but that you need to express it as affine.if and affine for in order to run the upstream loop.
Oh, and it's SEF?
It's SCF. So LLVM is doing its own loop optimization passes when that gets lowered to LLVM.
But we're missing the big ones, yeah.
But nothing from MLAR is applying to
And
that.
it's not affine because it isn't affine, or it's not affine because it's a pain?
It's not affine because we don't code gen it as affine.
I also
think-
don't
I think
know if
that's-
it is. I mean, it's semi-affine. There's floor divs in there.
Yeah, oh, well, I mean, like,
That's
MLIR affine, like.
Okay, yeah.
Yeah. I mean, it's ISL, so it's quasi-affine by
Yeah.
construction. So we should be able
We
to try, we could try that, right? Like we could try generating affine for nest and then running some MLAR loop optimization things on it.
I would
I'd
be
be deeply
surprised if
disappointed
there's
by that,
something
though.
smart enough in the MLAR loop optimization that would that ISL couldn't do. But
It's not that ISL couldn't do it, it's that we gave it a stupid schedule.
yeah,
And
but
that
it
Whatever the
like,
upstream thing is would not be burdened by that schedule, and it would just be looking at like the memory. I guess that's the other thing is that it's not memory. It's not like memory interface, right? It's memory effects is what the upstream passes use. But like it would just say like, okay, how many times are you assigning from this memory location to this memory? If the loop is inefficient and causing you to do like 4x extra assignments, then it might find a way to like remove one of the loop induction variables and provably get the same result.
but the dominating cost is like the size of the loop, though.
Right, and like, but it can tell that like, oh, it's this induction variable that is causing you to repeat assign the packing 4 times. Then you can just remove that induction variable and only do it once.
Yeah,
I think in general, like code genning affine, if it can be done in affine, is probably like a good idea, right? Unless it costs us anything in like additional support costs, because then we at least have the option to throw it into some later loop optimization pipeline.
Yeah, I'm trying to think why that should actually just be a pretty small fix. I'm trying to think why I even bother to write it directly in SCF. Maybe I can just swap it out immediately. So this issue is still open about this problem, this ISO slowdown thing for complex layouts. But yeah, the fix right now is to just increase the schedule. Let me go back to a little bit more in progress things. This one is fairly old. I'm trying to see if there's
Well, see
this support ML Orion ops, Lintrans, and OpenFHE backend.
Oh, isn't that like a? Okay, I think I'm not sure. I think this might be my PR, right? I don't know.
It's not that old. It's got a new number.
Well, I know I have been working on this as part of. Yeah, I think this PR we can actually probably close, but I have actually been looking at as part of adding the cheddar backend and looking into adding rational rescale and like precise scale tracking. I've also been looking at like doing better, like basically making Orion ops like a CKKS op level primitive and being. I think we had some discussion today about like deprioritizing OpenFHE as a backend. So I think honestly, this is probably I'll just close this now, quite frankly. Because the review load for me to like self-review this and then for you to actually like properly second opinion review it is not worth the effort at the moment. But we will hopefully soon have the ability to actually generate these ops to like nice pure CKKs and actually do it in the exact same error-free scale-free way. Scale error-free way, hard words there, to actually match basically how Latigo does it and how Orion wants it to be done.
Right.
And I think that's sort of what this was aiming to do, but then getting OpenFHE, like OpenFHE will never let you do it perfectly because OpenFHE thinks it knows better how to rescale things. And so in some sense, you would only get like I think I've gotten it down to the point where it only needs like one more prime in the chain if you target OpenFHE, but like it will never be as good with OpenFHE as it could be with Latigo or Cheddar or any of the other backends.
Right.
So yeah, I think we can consider this no longer in progress.
And then the other thing I want to call out from here is this draft guide. Jeremy, I still have to read it. So sorry about that. But
That's fine.
Jeremy started a draft guide for adding a new new backend to HEIR. So this should be useful for if you were to integrate the Cheddar backend or something.
Yeah, the reason I wrote this was because I also saw Jean-Philippe wants to add Pulpy as a backend to HEIR. And so I was like, okay, it's about time to write a doc.
Yeah.
Too many people.
I mean, unfortunately, I know the numbers don't make it look like, but I obviously did the Cheddar GPU backend before that dog existed, but it looks like the things I did. The one comment I have is basically there is the part where you add a backend and an emitter, and then there's a part where you have to completely rework HEIR to understand what the backend wants.
Yeah.
And I think with Cheddar there is some amount of work. With Pulpy, that is literally implement an entire new scheme in HEIR, right? Or like an entire new way of doing FHE and all the like associated ciphertext management. So I don't think there is an easy tutorial, even with Jeremy's amazing tutorial writing abilities. I think that is a tutorial that is impossible to write.
But yeah, I think just giving a picture of like what it looks like for the current backends and like what changes you would need to consider when, because like there is a section there for like a new FHE scheme. And then it's just like, well, this is a lot more intrusive and you're going to have to add a new dialect and, you know, you might need to change polynomial and all this stuff. So more just like a warning.
Yeah. Okay. I think that might be it on the stuff going on right now.
Sure.
Yes. Okay. Some recent issues that I wanted to call out was someone had filed a BERT gem lowering as well a week or two ago. That's sort of in progress. I have an understanding of like what needs to be supported there, why it's failing and everything. I will get back to it as soon as I'm done committing all my convolution changes. There's just a couple of places where we don't canonicalize things properly, where we don't support like certain things to be hoisted on the layouts. This one wasn't the broadcast. Alice's was the broadcast issue. This one was like a convert layout issue. And like it's actually slow to go from, like, we default row major pack everything. And then in this case, like, you would change into a different layout, and then doing that conversion was actually really slow because we didn't hoist that layout to the function argument. So we were still doing like a row major packing and then doing the conversion where you should have just hoisted it all the way to the top. I think that's actually why I might have made this as well, which just hasn't been reviewed, but it is ready. And then let me see. Yeah, this might have been the fallout issue from that as well. So that was like another part of this fallout. There's an issue about connecting Maple with HEIR. Maple is the work from Jianming and all group. This is Alice's issue that was at office hours. This was a bit of a frustration for me. I actually don't really know what to do about this. I would really like that to be resolved. I was trying to use integer range analysis on some secret blocked code, basically because when you preserve the loops, you might introduce an if statement, like Jeremy mentioned earlier. Those if statements might be trivially true. And if they are trivially true, I would like to remove them, because otherwise you might have some extra like multiplication masking going on and so on, or some you would end up passing in that extra zero arg. But if you run integer range analysis on code that has secret types in it, even like within that block, it'll crash because it'll propagate like an unknown bit width type for anything that came from a secret type. So that's preventing us from like canonicalizing away those trivial if statements.
But this should be easy to support because integer range analysis has an
interface.
Yeah,
it does. That type interface, I tried to use it. But the underlying issue is that type interface, regardless of the type interface, it still calls get storage bit width on a type in the actual analysis code, and that will end up running on a secret type at some point. And it's more like I don't need to extend the op interface of a generic. I need to extend that type interface of a secret type.
Okay.
But that shouldn't be unreasonable, right?
Assign that to me. I've also been reviewing the upstream code where they're like making dense elements attribute more generic so that it's not specifying to integer and float types. I think this would fit in the same, like there's an appetite for this upstream.
I can send you my my internal client change where I added the interface and everything. But still don't get it to work. But yeah, that's the root of it, is that there's like some function in there called like get storage bit width. Let's see. And then I think we talked about pretty much everything else. Someone reached out saying that they were interested in implementing CKKS and HEIR, like minus the stuff that's already been happening. I think they were just mostly curious as like a learning experience. Yeah, okay, I think that's kind of it. Oh yeah, and then my Linnet updates, yeah, a pooling layer. The first pooling layer currently takes 40 seconds. But I will work on that. But that means that in theory, Linnet should be able to compile, minus the fallout issues that I have.
Can I ask you what you mean by padding channels?
Yeah, so with the multi-input and multi-output convolutions,
Yes.
the way that we compute them is we create a giant Toeplitz matrix that just does a single matrix vector product in order to compute the multi-input, multi-output.
Yes.
In order to, when you have a strided convolution, there's going to be like many zeros in that big Toeplitz matrix because you'll have gaps between where you apply the filter. When you diagonalize that matrix, because when you do FHE computations, you would diagonalize this Toeplitz matrix in order to compute this MATVEC kernel. You want to minimize the number of non-zero diagonals. If you have like many zero diagonals, you can just remove the computation of the diagonal times the vector.
Yes.
So that zero diagonal optimization will come from interchanging the rows, that you align up those zero slots in a nice way. In order to interchange the rows, you need to have the gap of the stride be divisible by the gap of the stride squared be divisible by the number of channels.
The gap of the stride. Wait. The
So the stride is the gap.
Yes.
You want stride squared to divide the number of channels. So if your stride is 2, you could have a channel of 4.
Okay.
But if you don't have a channel of 4, then there isn't an even way to interchange and write this permutation. So you wouldn't be able to like interchange properly with like a channel of 3.
Okay. And so the solution is to add rows of zeros so that it's divisible by the stride squared.
Yep, that's it. Yeah, it's not complicated. I just haven't done it yet.
Okay. No, yeah. Thank you. Yeah, I understand.
Yeah, all there is to it is adding 0 rows and then applying the permutation.
Okay.
Okay. Topics for discussion. So you all mentioned you were discussing OpenFHE deprioritization. I already have a sense of that. But is there anything you wanted to mention about that?
And let's make this positive. Latigo prioritization, right?
Yeah.
I think you should share like the, new collaborators in the pipeline.
Right. And I mean, I guess we have some good news in that we have some people who will soon be eligible for T-shirts and mugs, because Mark is actively working towards his first PR on actually very similar things. So you might have guessed what he's working on based on the questions about the convolution and the padding. But as part of our work with Orion, Mark added a conv1d for an application where we need that. And it would be lovely to have that also in here. And I think it would be like a good starting PR. So that's going to be, I guess that's not necessarily related to Latigo prioritization, but that's the upcoming thing. And then somewhat more related to Latigo prioritization, as part of supporting Cheddar, which has incredibly strict expectations for the rescale schedule that you must observe in order to not get asserted at by the library all the time. We will be implementing precise scale analysis, and it's like custom rational rescale thing, which I think in theory should enable us to do other things. But as long as we use OpenFHE, it doesn't actually give us anything, because OpenFHE just throws all of our lovely analysis away and goes, I know better than you. And so that's kind of why I think we are very interested in using Latigo. It also helps that Latigo is just faster. There's more cool things being built on top of it currently, right? And obviously, for our priority, obviously, is Cheddar and our own GPU backends. But I think Latigo being already in Orion, being used already for all of our machine learning stuff is a natural focus. I think that kind of means that we also probably want to do things like consider making OpenFHE an additional Python package that you need to that we don't automatically package with it. And I think I really want to go back and look at how we can maybe start packaging things like Cheddar or Latigo as optional things to go with our HEIR packages. Because despite us not actually using the Python front end as much, one single tier, right? It's turned out to be really useful to have the Python packaging to be able to get people on board, right? It's so much easier. I mean, even for our internal use where we have a custom HEIR fork that it's public, but where we have a custom HEIR branch, it's been so much easier for me to just build 2 wheels now that they work and slap these in our internal repo than to ask people to please sit there for 20 minutes and rebuild LLVM. And so, yeah, I think the party is that between the rescale and the packaging and so on, I think we want to focus on Latigo and maybe some of the GPU backends, because those are the things we're currently working with, right?
Yeah.
Another thing, in the hour before this meeting, we were poking around Torch MLIR, and we think we found the place where we would add, the place where it takes a Torch node and produces an MLIR op and sets attributes. So we think we can extend that to do the intermediate value and any user forced polynomial degree stuff in a way that's compatible upstream by just having it be if it's if the Torch node has some metadata called custom attribute, then you take the name and the value and you would attach it to the attribute in MLIR. And so we think that we'll be able to support that in Torch MLIR pretty easily. And then, I mean, the intermediate value estimation is already done, right? We have a demo script for that. So that should make that pretty straightforward, I think.
Although the demo script that I have written, I think what I do is I take when you train, I take all of the min value, I collect all the min values and I collect all the max values per training run, and then I compute the averages of each of those. And I don't really know if that's the right thing to do. Maybe we need a confidence into maybe we take the standard deviation and then we go okay, 95% to 95% type of thing.
Well, I have a script that does quantiles, which I think just demonstrates that you can do any computation. So here, I'll link that in right here. So it's this Git repository, and that was doing the stable HLO, but the Torch part is the same.
Yeah. Right.
But why do you want to do statistics on it?
No,
I mean, why would you want confidence interval? Because if you saw, don't you need to take the actual min and max? Because if you saw it, you want to support it.
Yeah, I just said, what can we do in arbitrary computation?
Yeah.
So I just said, okay, let me just do something a little bit more complicated than min and max, just to demonstrate that you can put anything in there.
Actually, people have really high failure probabilities in FHE. So you might reasonably say, this model works really well and really fast if we cram down the ranges, but it's not going to work for all inputs. So
you could also say I'm willing to cut off the top and bottom 1 percentile to dramatically reduce the range, and then just take an accuracy hit for whatever is outside that range.
That's what I was kind of curious about. I was I mean, what if there's an outlier, right? What if there's one part and it's okay, then your accuracy loss is going to be very small. If there's just one outlier, but now your range is a lot tighter. So that was kind of the idea of doing statistics on it, but I don't know, to be honest.
Right, that's a trade-off.
That's interesting. That might be, you want to say I have 3 outliers. I just don't care at all.
If I can reduce the range of the polynomial approximation and get tighter precision and stuff on 99% of my data, and by throwing out 1% of it, then maybe that's worth it.
In our context, it might also be interesting to support open weight models where you don't want to retrain them, to say, okay, yeah, we can't retrain this, but we have to chop off a bit, a few percent of the distribution, but that allows us to support the exact model as is written. And it might even still give us better accuracy than if we went back and fudge with the model, because that's usually true. The FHE friendly retraining does lose accuracy anyway.
Yeah. Very
few papers manage to get it perfectly same accurate, right?
And sometimes when you screw with the ranges, you actually do get better accuracy.
Something gets better, something gets worse. It changes things, right? And so you might also just take a hit on some of the outlier inputs and be whatever, right?
Since nobody understands the black magic that goes on anyway.
Yeah.
Yeah.
Um,
Yeah, it's also
Oh.
it's also there that I think the HEIR folks, when they have like a really large range of activations, they do some technique that they had published last year on like applying an orthogonal like
Yes.
matrix on. Okay, so yeah, so I also don't know whether like that's the right approach to have when you have a large range. I don't know.
Talking about understanding the black magic on a different topic for a second, we need to add an issue to somehow explain like the high level flow of HEIR better. Because I feel like in the last week, I've explained this to like 3 or 4 different people. Obviously, David and you being one, or like in the last 10 days, but then also some external people. And I was like, wait, like our entire, like nothing in our docs actually tells people how the compiler like wants the like pipelines to combine, and like even something as simple as the idea that like the scheme dialect level is like the narrow waist is like not really written up cleanly anyway. I mean, it might be somewhere in the docs, but it's apparently people like I think we have like a high level design page that kind of does a bit of this.
But we have this picture.
Yeah, but like even that picture doesn't even have the narrow waist like visually.
Yeah,
right? So I think what we really need to do is like I have this like hand drawn Excalibur draw like mess that I pulled up. But I think it might make sense as we're increasing the number of people working on it to have like one page that's like, okay, here is how things can flow through HEIR, right? It might actually help for that also to not have torch lineage to CKKS anymore and just have that be like a flag on MLIR to CKKS. Makes like, saves like an entire paragraph of documentation writing if you just not have that duality.
I actually would rather see something like, you know, torch to lineage, and then I would rather see like
exactly.
MLAR to CKKS, and I even like I actually kind of want to split the MLAR to CKKS into being 2 parts. One is like the secret arith transforms that we do, like the arithmetization, and then the layout stuff. Like I think that those are 2 separate pieces of this, but yeah, that's so arithmetization, and then
plus, I think the broader question about the documentation though is like, do we think that the pipelines are stable enough?
Yeah.
That like the relative order of the big pieces isn't going to change too much.
I think the idea of having arithmetizations plus layout plus then ciphertext management, then we convert to real CKKS IR, and that's what the backends have to consume. But there's like that doesn't mean that any backend will accept any CKKS IR, right? And like there are flags in the higher level things that influence which backend. There's like module level scheme annotations on what the backend will be, and that influences like all of these things that are like super obvious to us. I think at this point are somewhat surprising to my colleague David, as I have like, which makes sense. Like that's a reflection on us and not on like him, right?
It's not in the video, but you see in the poster that Oscar made, there's this nice
This is one of the reasons why I wasted a lot of tokens turning that poster into a nice HTML page, because I think it's the closest thing we have, but it's a poster. So I think
that should go somewhere else as well. Yeah.
Maybe we can seal a few of the elements on that page and add some text to them. I don't know. I feel like we have a documentation specialist, unfortunately, but I'm also happy to take a stab at this. I think, explaining this, I think just explaining this should make it also easier. I'm really impressed with the student that came up and was like, I have a problem with putting bird gems through this pipeline. I was like, you managed to get this far? I was like, on nearly 0 documentation on how this works, I'm really impressed.
Same with Alice too. I was really impressed that she was able to support the lineage kernel like without having done any of the rest of the work. Like that was pretty impressive. But the problem that I have with this like ideal state of pipelines is actually trying to figure out this part. Like I know that it should be like, here's some pre-processing of your input, here's the arithmetization that you want to do in like the style of RLWE, and then we have like all of this stuff that just happens.
Yeah, I picked the order and it's kind of arbitrary, and like you kind of need to have lower level than lineage kernels to do management, but not quite, because that's how Orion does it. They don't implement any of their kernels before they do management. So it's unclear to me, and maybe there's like maybe the documentation should just kind of like say like, okay, well here's the here's the FHE part, and the FHE part is where we have to decide layout management parameters, and depending on the method, it can go a bunch of different ways, but these are the components of what needs to be included in this step.
Yeah, I think actually that's a reasonable way to have this, because I think like, for example, like ROTEM, right? Like, so if ROTEM would exist to subsume, or like
Rotom
parts of
would just
this.
do layout, but
Yeah.
then
The other
the
parts.
Orion,
Yeah.
sorry, not Orion, the
Orbit.
Orbit would
Yeah.
do management and parameters simultaneously.
Yeah. So I
Which
think
is
that
fine,
like
but I think-
most. Mhm.
Like, I think it's like there's a discussion on like if our thing is the optimal part, but just explain that these are parts and that
Yeah.
like
Yeah.
like I keep saying like, oh, you need to look at the management, and like the problem is like when I say management, like people look at the dialect, but that's not really helpful, right?
Yeah.
And so I think just I know we have some documentation for how management works, right? But I think having this like basically
Having links from all this to all the
Yeah,
different other
basically
parts
having
of
this
documentation.
notes thing, but like
Yeah.
5 times longer with like actual explanation of what's going on, it would be really nice, and it might also give us a reason to like clean up the pipelines a bit.
I mean, I can take this up. We have an internal sprint where documentation is like
Lovely.
part of that, and I think that maybe next sprint I can take that one on. So it'll be like
Yes.
Yeah, I think
Um,
that the nice part about organizing the pipeline this way in particular is that like let's pick on Edward. Let's say that Edward wanted to test like Orbit plus Rotom, that he'd want to run these 2 steps in isolation first and then call the Rotom plus Orbit part, because anyway this part for most people is going to be co-optimized in some way. Like there's going to be some interdependency between all of these parts. It's going to be hard to like integrate with like a specific part of HEIR's layout thing unless you would like understood what HEIR was doing and expected. So I think it makes sense to at least split the 2 here and the 2 here of the sandwich, and then keep the like middle part of the sandwich.
No, it's I dropped all of the
message or
we both weren't in the call with our personal devices when Ed sent the message, so we just saw his message pop up. And disappear.
Oh,
Side
But I
note,
think it was
Orbit
something
got
about
some great
Orbit.
reviews. Yay.
yeah. Wait,
all
sorry.
the questions?
Orbit was mentioned, but Orbit got some great reviews, so I think the paper is likely to get in. And then the questions that we got from the reviewers are actually some of the questions that are listed in the open discussion. So for example, they're asking about grafting, they're asking about automatic parameter selection, like how do you choose your bootstrapping budget and whatnot. But that's tangent from what we're talking about now.
Yeah, cool, awesome.
Yeah, okay, that's good to know. Edward, are you going to support grafting? Is that like next on the list of things that you want to look at?
This is something that we found out from the review, so we're looking at it now. It seems like something that we can support using our ILP. I think it actually seems pretty cool as well. I think the more important question here was something that Jeremy is getting at as well, which is if we have this like more precise like scale analysis, can we actually just tune our machine learning models to be like trading off performance for scale? And I think grafting allows you to do something along those lines where you can actually tune it to be even more precise. I think from my high level understanding of this, it's like you have like basically ultimate control on both scale and level. Yeah. But that would be like trading off, like finding out like, hey, for this particular layer, what precision do I need? And how much precision can I like get away with without degrading like my model accuracy that much?
Man, if only we had a machine learning expert who could tell us if that's an easy question to answer.
Yeah, let me think. I mean, I only brought up that grafting question because I maybe am trying to explore seeing if our intern wants to support that. I should ask Jianming too what his plans are about grafting, because
like, do we is there a good explanation of like, I think like there is an explanation of composite scaling versus grafting or something on like out on the internet there, but that's not really helpful because I understand like those are very different ideas. Is there an explanation of rational rescale versus grafting somewhere? Because that's what I'm currently like banging my head against, and I haven't invested the proper time to like read the papers carefully enough, but I feel like it shouldn't be as hard as it has been so far. I mean, composite you can keep out there. Composite is really just a like hardware bit width hack, and it's completely subsumed by like the other techniques. But rational versus grafting, they're clearly doing similar, like they're coming from similar directions, but they seem to be doing something very different, or at least presenting it in different enough languages that I struggle to like really apples to apples compare them. And if somebody already has done this comparison, for example, and would like to write them on their blog or something, you know,
rational
I've already
like,
asked the usual suspect and he hadn't. So now Ed,
you
you're my
mean rational
second.
rescaling for like precise like modular, not just like bit width matching, you know, the RNS bit width to like an approximate version, but you mean like actually dividing the two scales. I think grafting completely decouples the two, like completely decouples your modulus with that. So I mean, I know they have to be different, but to be honest, I haven't like understood the process of grafting enough to know.
That's kind of the stage where I'm now at, and I was like kind of hoping, hey, maybe somebody who looks a lot at rescaling techniques, you know, not looking at any specific participant, right? I don't know if Ed, if you got that, but yeah, maybe somebody happens to have already thought about this and can give us a good explanation of like a short write-up. If not, I will make one, I guess. But yeah, I think it's really interesting. They like the Cheddar basically forces us to do some sort of rational-ish rescale because it like literally asserts at you if you don't. But it like, yeah, if there is some generalization of the two ideas that allows us to like treat them as the same and just parameterize them, even better, right? Yeah,
So I
because
will say,
definitely
like, Cardamom
ahead.
also does the same thing for rational rescales, but as for grafting, this is something I like heard about like 2 days ago. So fortunately, I'm in the same boat as you, where I haven't.
Okay.
All in that boat. Yeah.
Okay, now I'm starting to run out of people. I can hope will have already thought about this.
Well, I mean, remember who's the author was a HEIR hopeful. A grafting blog post. Remind me.
The grafting book. So the grafting paper was written by the Crypto Lab people. So
No, there was someone who wrote a graphic.
Blog post is nice, but it's Johannes
Johannes, yeah, Johannes was a HEIR contributor. So
right,
can we
right.
just should I ping him on Discord?
I was like, I'm going to Bochum to visit my parents in a week or two. Can I like, how much beer do I have to buy him / buy him lunch to get him to explain this to me?
Let me ping. I'll see if he's willing to give me the short answer.
Yeah. Okay, but yeah, I think this is something that we care about by sort of necessity of all the cool GPU backends are doing the rational thing now, and so I guess it's time for HEIR to learn how to do this.
Right. Okay. Wait. This is. I forgot that this blog post existed. This is great. I need to read
The
this
blog
today.
post is very lovely, but it's unfortunately high level enough, and like it's a lovely presentation of grafting, but it does sort of.
It kind of puts the problem to the side.
Yeah, like it answers a lot of the questions I didn't have.
The question was the difference between rational rescaling and grafting, or is there something more specific?
I think, yeah, like what at the end of the day, like, are these really fundamentally different techniques? Because
They must be different, right? Like, I mean, grafting is like much more
because
general.
FHE has never invented the same thing under different names multiple
Okay.
times.
Yeah.
Like about like half the schemes being the same scheme.
I don't remember who it was that said that grafting the idea was also in the HE paper.
I don't know. Like this is my point. Like I feel like we're now in the rescaling world. We're at the same point we were for like key switching like 3-4 years ago, when like every couple of weeks there would be like a completely new idea, and then like a year later everybody would slowly start to realize that these are actually just like puzzle pieces of the same idea. And I'm hoping we can sort of skip that part of the process by understanding how exactly these two relate.
Okay, I
Oh
pinged
my
him.
goodness. They also had to invent a special machine word, a sprout, and we call it a universal sprout. Oh no, there's more words.
Okay, the grafting folks have way cooler
Yeah.
names. Like I think Cheddar calls the rational like auxiliary primes, which is just you know,
Okay, yeah. I know
That's the term I know, but
yeah.
Yeah.
But Sprout
Okay.
definitely stays with you.
But yeah, so I think maybe by the time we meet again for this in a month, we'll have an amazing documentation on not just what these are, but how HEIR does them.
Yeah, I mean, to be fair, I do want to read. Yeah, Jeremy, if you hear back from Johannes, send it over to me, because I do actually like need to write an intern proposal doc on something that would be useful. So
I do have something. So I now have access to a closed source implementation of the ship bootstrapping method. It's CPU. And so we could port that to, I was going to ask Jianming to port it to JackSite, but we could either implement it in HEIR directly or have the intern also port to JackSite. A little bit of a side note, but I don't know if that would be too hard for an intern project, but that's a potential option.
yeah, I just need to think of like the right thing that would be like, yeah, cool, I did it. And we have a cool like demo and talk for them to do at the end. Like, okay, if they do bootstrapping, can we show them? Like if we don't have a baseline bootstrapping implemented, I guess we have baseline and
I think this would live alongside the standard bootstrapping method that Eric is working on.
Right, yeah. Okay. Any other random discussion topics too that people want to bring up that I might not have touched on?
Less a discussion, but just a follow-up question to that. Is Eric implementing like dense, full bootstrapping, I assume? And so I guess whatever ship is, I don't know what it is, but I assume between that and like, between Eric's and that, there's probably just normal sparse bootstrapping as well.
I don't know if he's doing sparse or dense. I mean, I assume.
Actually, I'm not even, is it sparse or dense or is it sparse and full? Because FHE sucks at naming things. But yeah, I think that would be a good question to follow up with on.
I don't know.
For Eric.
I don't think we've decided what
Okay.
specific bootstrapping method we'll implement, but hopefully it would be closer to the Latigo ephemeral sparse secret than
Yes.
than OpenFHE, because I know that's faster, but we'll have to see.
Cool. If so, I can stop the recording and we'll have 5 minutes to talk about anything that doesn't need to be recorded and or leave.